In this video, we are going to look at more concept. This is the branch of chemistry that deals with the calculating of substances before and after a reaction has occurred. Now, there are some basics that we need to have in mind, like we need to know the mass number. Okay, let's say we have an atom where we have the mass number here, and always we need to remember that the mass number consists of the protons number and the neutrons number. So if you add the protons number and the neutrons number, you get the mass number. Now for the number below here, this is known as the atomic number. So the atomic number represents the number of protons and the number of electrons before a reaction has occurred. Now, away from there, we need also to have this definition for stoichiometry, which is the area of chemistry that deals with the calculating the amount of substances before and after a reaction has occurred. Now also we also have to look at the quantitative relationship, the determination of how much of a given component is present in a given sample. Okay, now there are 3 points that we are first going to begin with. One is relative atomic mass. So relative atomic mass. Then the second one, we have relative molecular mass. The third one is relative formula mass. Now the first one, which is the relative atomic mass, is just the average mass of one atom of a given element. For example, let's say we have an atom of sodium with the mass number of 23 and the atomic number of 11. So if the question were to be asked what is the relative atomic mass, the relative atomic mass denoted by AR is equal to its mass number. So the relative atomic mass, you just get the mass number of a particular element. Now for a relative molecular mass, this is now the sum. This is just the sum of all the relative atomic masses of the atoms that make up a molecule. For example, let's say we have water, we have ammonia, then also we may have compounds like, apart from ammonia, we may have carbon dioxide. So here under relative molecular mass, we are trying to find the mass of all the relative atomic masses of a compound. Now remember, for a relative atomic mass, the compound must be a covalent. So here we are dealing with a covalent compound, and we know that a covalent compound, it is a compound that consists of nonmetals, where the type of bonds that exist in covalent compound is where the 2 or more atoms are sharing a pair of electrons. Now for the relative molecular mass, here we are dealing with the sum of all the relative atomic masses of the ions. So here we are looking at the ionic compound, such as if we have sodium chloride, let's say we also have aluminium phosphate, Then we may also have sodium hydroxide. So the first step for relative molecular mass, the compound must be ionic compound. So the difference between relative molecular mass and relative molecular mass is that relative molecular mass deals with a covalent compound, while relative molecular mass deals with an ionic compound. Then we know that for us to get an ionic compound, we need to have a bond between a metal and a non-metal, where we are expecting to have the transfer of some electrons from one element to another element. Okay. Now, after knowing the difference between the relative atomic mass, relative molecular mass, and the relative formula mass, let's now look at some examples. So we can just say we'll begin with finding the relative formula mass. So say calculate the relative formula mass of the following. The first one, we'll look at aluminium phosphate. So aluminium phosphate. So let's find the relative formula mass for this compound. So we have Mr. The symbol for relative formula mass is Mr. Mr. So here we need to multiply the number, the element times the number of atoms present in a given compound. For example, here we are saying aluminium. Aluminium will be multiplied by, we have 2 atoms of aluminium, so aluminium times 2 plus. Now, for a compound where we have a part that is in brackets, here we are going to multiply the subscript outside the bracket, multiply by everything inside. So let's look at first the number of atoms for phosphorus inside. So we can see that here we have 1 atom, and for oxygen we have 4 atoms of oxygen. So each element inside the bracket must be multiplied by the number outside. So we'll say phosphorus multiplied by 3 plus oxygen. Now for oxygen we are going to multiply 3 times 4, which is now oxygen times 12. Now from there we can go on the periodic table. So on the periodic table we have aluminium with the mass number of 27, the atomic number of 13. Then also we can look at the phosphorus. The mass number is 31. Then the atomic number is 15. Then we can also look at the oxygen, where the atomic number, the mass number is 16 and the atomic number is 8. Remember, whenever we are dealing with the mole concept, always use the mass number. So we are going to use the mass number. So where there is Al, we are going to replace with its mass number, which is 27 times 2 plus phosphorus 31 times 3 plus oxygen 16 times 12. So here we can see now 27 times 2, which is 54. So we get our 54 plus 31 times 3, we have 93. So we get 93 plus 16 times 12, 192. Then we can add. So 192 plus 93 plus 54, we get 339. So this is our final answer for this problem. Let's have another example. let's say this time we are finding the mixture for sodium chloride. Then for sodium chloride, the sodium has the mass number of 23, the atomic number of 11. Then for chlorine has 35.5. Then the atomic number of 17. So let's begin. So we can see that from the compound, we have one atom of sodium and also one atom of chlorine. So the ratio is 1 to 1. So we can say sodium times 1 plus chlorine multiplied by 1. So here the mass number for sodium is 23 times 1. For chlorine is 35.5 times 1. So 23 times 1 is 23. 35.5 times 1 is 35.5. Then 23 plus 35.5, we get 58.5. So this is our relative formula mass, because we are still looking at ionic compound. Okay, let's have another example. This time let's have ammonium chloride NH4Cl. So we can begin. So we can see that there is one atom of nitrogen plus we have 4 atoms of hydrogen, so hydrogen times 4, plus 1 atom of chlorine, so Cl times 1. From there we are going to replace with their mass number. So the mass number for nitrogen has the mass number of 14, then 7 here, so we can see that we are going to have 17 times 1 plus hydrogen is 1 times 4 plus chlorine is 35.5 times 1. 17 times 1 is 17 plus 1 times 4 is 4 plus 35.5 times 1 is 35.5. So now we can add 17 plus 4 plus 35.5, we get 56.5. So this is also another relative formula mass, because ammonium chloride is an ionic compound. Okay, now let's move on. Let's look at the relative molecular mass. So now for relative molecular mass, we said here we are going to find the mass or the masses, the sum of the masses for a molecule or a covalent compound. For the first one, we'll look at number 1. We have water. Number 2, let's say carbon dioxide. Number 3, ammonia. Then let's say we also have methane. Okay, so you can pause the video and try to work them out. So the first one, let's look at the mixture for water. So from water we can see that we have 2 atoms of hydrogen, so hydrogen times 2 plus 1 atom of oxygen multiplied by 1. Then the mass number for hydrogen is 1 times 2, 16 times 1. So 1 times 2 is 2, plus 16 times 1 is 16. We get 18. So this is now our relative molecular mass, because water is a covalent compound. Let's look for carbon dioxide. So for carbon dioxide, we are going to say, so here we can see that there is 1 atom of carbon, so carbon times 1 plus oxygen multiplied by 2. The mass number for carbon is 12 times 1 plus, here we have 16 times 2. 12 times 1 is 12 plus 16 times 2 is 32 plus 12, we get our 44. Okay, let's check for ammonia here. So we can see that the relative molecular mass for ammonia, there is 1 atom of nitrogen, so nitrogen times 1, plus there are 3 atoms of hydrogen, so hydrogen times 3. So here we have 14 times 1 plus 1 times 3. 14 times 1 is 14. 1 times 3 is 3. We have the total of 17. Let's look at the last one, methane. Here we are going to have, we can see that there is 1 atom of carbon, so carbon times 1 plus hydrogen, 4 atoms of hydrogen. So we can see that 12 times 1 plus 1 times 4. 12 times 1 is 12 plus 1 times 4 is 4. 12 plus 4 is 16. So this is how we can calculate the relative molecular mass and the relative formula mass, including the relative atomic mass. Okay, now let's move on to moles. Now, sometimes it may be difficult for you to understand a mole, but let's compare or illustrate the word mole to a dozen. So if I say I have a dozen of eggs, it means I have 12 eggs. So a dozen means 12. If I say I have a dozen of pens, that means 12 pens. So a mole is also a fixed particular number. So like for example, if I say I have one mole, so 1 mole is equal to 6.02 times 10 to the power 23. Then also you need to remember that this number is also known as Avogadro's constant. So we have what we call Avogadro's. So Avogadro's constant number. Then from there also we need to know that this Avogadro's constant is denoted by capital letter N and the capital letter A as a subscript. Now also we need to know that we can find the number of moles by using Avogadro's constant. So the first formula that we are going to use for us to calculate the number of moles, and remember, number of moles can be calculated by using so many formulas, but what determines the formula that you are going to use is the data that you are given in a question. So the first formula that we are going to look at for the number of moles is, so say number of moles is equal to, so you can say number of particles on top, number of particles. So number of particles, this can be atoms, molecules, or ions, divided by Avogadro's constant. Now in symbols, number of moles is denoted by small letter n. Then for the number of particles, here we have letter x. Then for Avogadro's constant, we have Na. So now, if you have a question where you may be asked to find the number of atoms or molecules or ions, therefore you are solving for x, so you need to make x the subject of formula. Then for the number of moles, you may be given, or you can use the data from the question and calculate the number of moles. Then for Avogadro's constant, this is a number that must be known. So it is 6.02 times 10 to the power 23. So this number must be a known. It's a constant number. So let's say we have the first example. So here we have calculated the number of moles in 3.01 times 10 to the power 23 atoms of aluminium. So here we have been given the number of atoms. So the number of atoms, we can see that we have been given the value of x, because x denotes the number of atoms or molecules or ions. So here we are solving for the number of moles. So you can say number of moles is equal to our x, which is the number of atoms, divided by Avogadro's constant. So let's now substitute x here. We have 3.01 times 10 to the power 23 atoms. So 3.01 times 10 to the power 23 divided by the constant number 6.02 times 10 to the power 23. So we are going to use a calculator, and make sure that if you are calculating numbers like this, you put them in parentheses or brackets. So we have 3.01 raised to the power 23 divided by 6.02 raised to the power 23. So here if you divide 3.01 times 10 to the power 23 by 6.02 times 10 to the power 23, we are going to get 0.5. The units for moles are moles. So we can see that the number of moles in 3.02 times 10 to the power 23 atoms of aluminium. So this aluminium has 0.5 moles. Okay, let's have another example. So now the second one, calculate the number of molecules in 7 moles of water. So from the data, we can see that we have been given number of moles, and the question is, we are trying to find the number of molecules. So the formula is number of moles is equal to x divided by Avogadro's constant. So here we can see that we are solving for x because we are looking at the number of molecules. So over 1, so that we can make x the substitute formula. So 1 times x is x. Then here we are going to have number of moles multiplied by Avogadro's constant. So the number of moles, we can see that we have 7 moles multiplied by the Avogadro's constant is 6.02 times 10 to the power 23. So we can use calculator now, times 6.02. So we have 4.214 times 10 to the power 24, since we can now say molecules, since we are looking for molecules. So this is how you can answer. So remember, we are saying we can now summarize the moles is the amount of substance that contains the same number of particles as the number of carbon-12 atoms in exactly 12 grams of carbon. And we also made a comparison. We can compare the number of moles to a dozen, where the number of moles represents a fixed number, which is also known as Avogadro's constant, that is 6.02 times 10 to the power 23. So this is our first step that we can use to find the number of moles, and that's it for this video. Please share and don't forget to like and subscribe to the channel.